Okay, so welcome back again, and this is the Chipmaster here, and in this video I will do another laptop repair on a Dell. Right, it's a Dell Latitude 7480, and he said that it turns on and it doesn't display anything on the screen. Right, so it's a no display fault. Alright, and it's a 7th generation CPU, as you can see. 7th gen. i7. Alright, so we're going over to the overhead. Alright, so it says 7480. Right, the latitude 7480 there. Yeah. And the fall phenomenon, it's that it's not displaying, no display. Alright, so I'm going to plug in the power. Right, and I press the switch. Pressing the power button. I see turns on. It said that it's not displaying, but I'm not getting anything. Okay, I'm now getting 590 milliamp. I'm not seeing any lights here. There's a white light, should be here and at the front here, but I'm not seeing it. Power's off. I turn it on again. I see the screen flashes a while ago. $660. And the current is jumping between some 590 milliamp. Shuts off. Press the switch again. 660. I see a flash in the screen there, like it get dark, so that indicates that the screen is getting its power. And then it goes to 590 milliamp. $660. All right. So it turns on, doesn't display. Current jump between 660 milliamp to 590 milliamp. Then it goes to 300 milliamp, 70 milliamp, and then powers off, I believe. Okay, I remove the battery. Let me remove the RTC battery. These the latitudes of RTC section here from the battery. The cap there. This one is tight. All right, give power again. You see that flash in the screen, and it's not turning on anymore. I think the port is having a problem. Alright, so I'm getting a flash here. So I get 1, 2, 3, 4, 5 and 2 amber. 2, 3, let me count it. 2 amber, 2, 3, 4, 5. 5 white and 2 amber. Alright, so it says that it's 5 white on the Dell official website, says that it's a memory related issue. Let's see. So I'm removing one RAM. Alright, so it says it's a memory issue. Let's see. So I'm trying one RAM at a time. Okay, it's going to power on again. Alright, there we have lights in the keyboard now. So it seems that it definitely was a RAM problem. There we go. We have display, and I got display on the screen there. All right, so I'm now checking the RAM here. So it was indeed the RAM. So I will connect the RTC battery back. Oops. Let me connect the RTC. I'm actually plugging in back the RAM. This is a 8GB RAM, and this one is a 8GB, so it's 16 gigabytes of RAM there. Just inspecting the memory slot. Alright, so I'm powering up the unit again. Alright, so as you can see, I'm now getting back the amber and flashing lights. So I'm going to clean. Don't see any oxidation on the RAM. Let me try this slot. Just checking if it's a slot problem. Right, so it's now on. Yes, as you can see, it's flashing. 2 white. So it's definitely a slot problem. This is a slot problem. Right, so the slot is bad. Yes. So I will have to replace this slot, because the customer will need to use their full maximum memory. So I can't just give them and with the 8 gig, so I'll have to I'll have to replace the memory slot. Alright, so I'm going to disassemble the machine. Okay, so the motherboard, the laptop is disassembled. Right, so as you can see here, I have this is the board I'm going to repair, and this is a donor board. Right, so I'm going to take this one off. Right, so because of time I won't show the entire process. I'll only show the lifting process under the BGA. I won't show when to solder because of time, and that will be a long boring video, so I will just make this short and quick. So I will remove the slot. Right, this is the one I want to repair. This one I'm going to replace this one, so I'm going to replace this one with this one. Right, you get it? Okay, so I'm going to do the prepping. Okay, so the slot, this is the good slot, it's now off. So I will now remove this one, which is the bad one. So I make sure I remove the good one first. So I have the good one here. So I will now replace the bad slot. Okay, so now the slot, the RAM slot is going to be replaced. Alright, so I will now start the machine and get back to you when the soldering process is finished, when I will lift this RAM slot from the board. Okay, so I'm now at 215 degrees. Alright, so I'm going to do a nudge to see if the RAM slot is actually ready. As you can see, the bubbles are starting to, the flux is starting to boil, sorry, under the RAM slot. So I'm going to, yes, it's almost there. It's getting there. As you can see, I'm actually moving this slot now, as you can see. Right, we don't want to put any force because it will tear the leads, and that's going to give you more work. Right, it's almost there. There now? Yes, it's ready. Alright, so the slot is now removed. Trying to get a focus. Alright, so I let the board cool and then do the soldering. Okay, so the slot is removed. As you can see, no pads are torn, all intact and ready to receive the new replacement slot. Right, all pads are intact. So I will solder this slot to this pad here and get back. Okay, so the slot is now soldered and replaced. Right, so I'm going to test it. Okay, so I have this schematic of the RAM slot here. So we have some key signals that I now want to check, such as this one, which is the write enable, right? So write enable, which is after the RAM is passed, right? So before the RAM is passed, sorry, when the CPU gets the reset signal, then it will go through the DMI bus to read the RAM, right? So it will go through the DMI bus internally inside of the CPU to read the RAM, right? Once it reads the RAM, then it will now dump the BIOS into the RAM. So that is the aim of the soft start, right? Once the CPU gets the reset signal, right, so it will go through the DMI bus internally inside of the CPU. We can't see it because it's inside of the CPU, right? And it will go to the PCH, and the PCH will now start the addressing, right? The CPU will now start the addressing, and the CPU will accept that command, and then what? Read the RAM. After reading the RAM, then it will send back to the CPU that the RAM is all intact. Now you can start writing data to the RAM and start the initialization process of initializing the integrated graphics card, right? So I'm going to check some signals, right, to see if all is well, right? And then now I can say that the RAM is ready. The RAM has to be in it for some of these signals to be executed. So I'll connect the RAM. Right, there we go. So I'll connect the RAM, and I will demonstrate on checking these key signals. Okay, so pin 151, which is write enable, right? And we have on die termination. This should be in a high impedance. This is an internal resistor that is inside of the CPU, which is going to test the impedance of the RAM, right? So if the signal is not coming, then you can't get a display, right? So this is ODT, which stands for on die termination, right? Because the on die termination is used to test. That is why we have the resistors. There are some small resistors, right, that are on the RAM, right? There are some small resistors on the RAM, right? There. We have some termination capacitors here, and we have termination resistors here. So this is used to measure the impedance, right? Because of the high transfer of data back and forth to the CPU, and from the RAM to the CPU and back and forth, right? So it needs to test the integrity of the RAM to make sure that the data is not disappeared or lost during the transmission of signals, right? Because it's a high frequency. So the on-die termination will now test each of these RAM banks, right, to make sure that they are ready to receive the data, right? And also these are used for impedance matching, right? So on-die termination is for the termination, all right? On-die termination, which is for impedance matching, right? So please bear that in mind. Okay, so that's on-die termination. This is about 0.7 volts, right? On-die termination, we can check that also. And we have row address trope, and we have column address trope. This is how the data is going to be written, right? We have chip select, right? And we have some other signals, but I won't check these. I will only check on-die termination, and I will check write enable. Once the write enable is ready, is there, that indicates that all the RAM modules, right, are intact, right? The power supply is intact. The reset is intact, right? So this is the last signal, and then after the write enable, then we have DQ, which stands for data. So we have DQ60, DQ0, all the way to DQ64, right? So we have DQ57, right? DQ60, right? DQ, and that indicates that's a 64-bit computer system in it, right? So from DQ0, this is all mixed up on this board. Normally on the Quanta boards, they will normally put them in rows, right? 61, so it stops at 63. All right, so DQ63 is the last one, and this is all jumbled up. All right, so DQ, I'll see if I can find it. DQ63, DQ63. Let's see if we can find it. Yes, here it is, DQ63, which is the last one, right? These are data lines, right? Any of these data lines are not intact, they will get no display. So the write enable cannot execute, which is on pin 151, write enable, right? So pin 161, pin 161 or 151. I think it's pin 151. Pin 151, yes. Right, pin 151, as you can see, the signal is called DDR underscore B underscore MA, right, underscore 14, MA 14, right, pin 151, and it's right here. Right, so it's the fourth pin from the gap. Right, it's the fourth pin from the gap. Right, so I will check with oscilloscope. First of all, I need to check on-die termination. This signal must be in a high state or high impedance state during the entire process of the soft start, right? So I'll need to check on-die termination. So on-die termination, right, is, let me check. Right, so on-die termination, which is pin number 155. On-die termination is pin 155. Alright, so I'm going to head over to the schema. See, on-die termination, which is pin 155. Right, so pin 155. Pin 155. And that's the 1, 2, 3, 4, 5, 6, the 6th pin from the gap. Right, that's 1, 2, 3, 4, 5, 6, and this is about 0.7 volts. This is roughly 0.7 volts, right? So I remove the RAM because it's on this side. Right, so I'm going to go over under the microscope. So on the microscope side here. Alright, so I'm going to open the multimeter here. Right, on-die termination, this voltage is about 0.7 to 0.8 volts. Right, this voltage must be high. If this voltage is not coming, then the CPU memory controller is not working in the CPU. You should replace the CPU. Right, if this signal is not coming, right, replace the CPU. CPU is the fault. Alright, so let's go on to pin the 7th pin from this gap. 1, 2, 3, 4, 5, 6, 7. Alright, sorry, it's a 6th pin. It's a 6th pin from the gap. The 6th pin. 1, 2, 3, 4, 5, 6. Right, so I'm going to give power. One, 2, 3, 4, 5, 6. All right, let me plug a RAM in. Four, 5, 6. There we go. So we have 0.4 on this board is 0.4, right? So if the RAM, I forgot, the RAM has to be in there, right? So if I remove the RAM on the other slot and check 1, 2, 3, 4, 5, 6. All right. So as you can see, the RAM is not there. Zoom out. Right, so there's no RAM in the slot, and I give power. As you can see, the current is 460 milliamp there, and I'm not getting any voltage, right? So I'm removing the RAM. I'm installing back the RAM in this slot, and I'm going to give power. See, 0.4 on die termination. So the RAM has to be in there, right? Sorry, it was my error. The RAM has to be in there. So on die termination is present. Now, to get the right enable, I have to get the RAM in, and well, I'll just use this RAM because there's two RAMs. So the RAM slot is there, so I'll just use this one. So as a reference, so this one has to be in there at all times to get these key signals, right? So the right enable, right? The right enable, as I said before, is pin 151, right? And pin 151 is the third pin, the fourth pin from the gap. Right, so I'll get the oscilloscope ready. Okay, so now I have the oscilloscope ready. As I can see, I have the probe here, right? So I'm testing the slot that I just changed. Remember, this is the slot I'm interested in, since this one is okay. So now I'm going to connect the oscilloscope probe to the pin of the right enable. That's why I soldered a wire. The RAM has to be in there, and it's under it, so I have to solder a wire and then protrude out so I can connect my oscilloscope probe. Alright, so I'm going to give power. Now take a look at the screen of the oscilloscope. Alright, after the RAM is read, right? After the RAM is read, right? So the RAM is going to be read by the PCH inside of the CPU, right? And that takes roughly maybe about 5 to 6 milliseconds. After 6 milliseconds, then the RAM will actually start the writing and reading process. So the write enable signal is intact. On die termination should be in a high impedance state during the soft start process, right? Because of time, I cannot explain everything on the oscilloscope on this part because it's a very in-depth topic, right? So I'm going to give power. Right, so it's on. So as you can see, the data is now being written to the RAM, right? See, there we go. The data is written. All right, see, the CPU is now writing the data, and as you can see, everything had passed there. Right, so it powers off. It's going to power on again. There we go. Right. So I'm going to check. All right. Now see, I have caps lock, as you can see now. Turn off the light. As you can see, I have caps lock. So the RAM slot is now working, and the RAM has passed, as you can see. Right, so the data is not continuous. As you can see, the laptop is now on, and on the oscilloscope screen, there is no waveform. So this signal only comes within a fraction of a few milliseconds. Right, so the RAM, once we start to open programs, right, and other applications, then this waveform will execute again, right? So there's a constant communication between the RAM and the CPU memory controller inside of the CPU. So as you can see there, I have caps lock, and that's a complete job there. Okay, so now I will just assemble the unit and show you the end results. Okay. Okay, so the machine is now assembled. All right, connecting the battery. All right, connecting the back cover. Just double checking, making sure that everything is intact. All right, so, oops. All right. Alright, so give power. I'm powering off battery now. It's still on. Alright, so it's doing its power cycling for the RTC section and the ME, configuring back the ME module. There we go, and I have a Dell there, logo, and saying that the time of day, F1 key. So ME firmware, right? Yes. So it's configuring back, then it should start to boot. There we go. Alright, so there we go. Job is finished. Right, so the job is done. This is the slot that was causing it, so I can't give back the customer with only one 8 gig, so I have to replace the slot so they can have their full RAM, 16 gig of RAM, based on the type of work that they are doing, right? So I hope you enjoyed the video, and I hope you like it and subscribe for those who haven't subscribed, right? And as you can see, I've done the job, so I'm going to start the day of work. Alright, so I see you in another video when I repair something for you. Okay, bye.